Welcome back to Paper Pills, the podcast where we unravel intriguing research papers and try to make sense of them. I'm Abby.
And I'm Carl. Today, we're looking into a topic that's a little bit spooky: near-death experiences.
Exactly. We'll be exploring a 2022 paper titled Enhanced Interplay of Neuronal Coherence in the Dying Human Brain, which details a captivating case study that might offer a glimpse into what happens in our brains when we're on the brink of death. Near-death experiences, or NDEs, are often described as profound, sometimes even life-altering events. People who've had them report a range of experiences, from out-of-body sensations to feelings of euphoria, and very often, a rapid replay of memories, sometimes described as their life flashing before their eyes.
Yeah, it's a common trope in movies and TV shows, that moment of intense crisis where the character sees key moments from their past. But despite the widespread anecdotal evidence, the science behind NDEs is still quite limited. We don't really understand what's happening in the brain during these experiences.
There are theories, of course. Some suggest that the brain releases a flood of chemicals under stress, leading to hallucinations or altered states of consciousness. Others propose that it's a spiritual experience, a glimpse into the afterlife. But until recently, there's been little hard scientific data to support any particular explanation. The neurophysiological processes underlying near-death experiences have remained largely a mystery.
Exactly. This is where this paper comes in. It offers a unique look at brain activity during the dying process, potentially shedding light on the mechanisms behind those vivid memories and sensations reported these moments.
So, Carl, this study we're discussing today stems from a rather unique and somewhat accidental event. Back in 2016, doctors in Estonia were performing a standard electroencephalogram, or EEG, on an 87-year-old patient who was experiencing epileptic seizures.
Right. EEGs measure electrical activity in the brain using electrodes placed on the scalp. They're commonly used to diagnose conditions like epilepsy, sleep disorders, and other neurological issues.
So, during this routine EEG, the patient unexpectedly suffered a fatal heart attack and died. This unfortunate event inadvertently provided scientists with the first ever continuous recording of human brain activity during the dying process.
It's a morbidly fascinating opportunity, really. They were able to record about 900 seconds of brain activity, including the 30 seconds before and after the patient's heart stopped. This data allowed them to analyze the different types of brainwaves present during this transition period.
And just to give our listeners a quick primer on brainwaves, these are essentially rhythmic oscillations of electrical activity in the brain. There are 5 main types: delta, theta, alpha, beta, and gamma.
Delta waves are the slowest and are associated with deep sleep. Theta waves are slightly faster and are linked to drowsiness, meditation, and memory formation. Alpha waves are present when we're awake but relaxed, often with our eyes closed.
Beta waves are faster and are dominant when we're alert, focused, or experiencing anxiety. And finally, gamma waves are the fastest and are associated with higher cognitive functions like learning, memory, and conscious perception. So, by analyzing these different wave patterns, the researchers hope to gain insights into what's happening in the brain as it approaches death. One of the most striking findings from this study was a surge in gamma wave activity in the patient's brain just before death. Gamma waves, as we mentioned, are typically associated with heightened cognitive processing, focused attention, and, importantly for this discussion, memory retrieval.
Precisely. This surge in gamma waves, particularly in frequencies associated with memory access, suggests that the patient might have been experiencing a flood of memories, potentially their entire life flashing before their eyes, as anecdotal evidence from near-death experiences often suggests.
It's a compelling finding.
However, one big limitation of the study stems from the fact that this is a single case study. While it provides intriguing insights, it's crucial to replicate these findings in other dying patients to confirm that this pattern of brain activity is a general phenomenon rather than unique to this individual.
Absolutely. Moreover, his research also underscores the importance of ethical considerations and the sensitive nature of studying such a profound and personal experience. This Estonian study isn't the first to look at brain activity during death. There's been prior research in rodents that offers some interesting parallels. Similar to the human study, researchers observed a surge in low gamma frequencies in rats 10 to 30 seconds after cardiac arrest. So this spike in gamma activity might be a common occurrence across species as the brain transitions to death.
Right, and that cross-species similarity strengthens the findings. But there are also some key differences. While both studies showed increased gamma, the Estonian study found that this increase persisted even after cardiac arrest, specifically in terms of relative gamma power. This wasn't observed in the rodent studies. Additionally, the way different brainwave frequencies interact seems to differ.
I've read also that in the rodent brains, delta, theta, and alpha waves modulated low gamma activity after cardiac arrest. However, in the human brain, it's the alpha waves that predominantly drive the modulation across all gamma bands, even after the heart stopped. This interplay between alpha and gamma is very interesting.
It is, especially considering that alpha waves are typically associated with a relaxed, yet awake state, and are thought to suppress irrelevant brain activity. Gamma waves, on the other hand, are linked to conscious perception, focus, and memory retrieval. The strong coupling between these two during the dying process might explain the reported phenomenon of a life review.
It's like the alpha waves are quieting the noise of the external world and internal anxieties, allowing the gamma waves to facilitate a rapid retrieval and replay of key memories, almost as if the brain is conducting its own final, deeply personal retrospective. It's a compelling thought, though much more research is needed to truly understand what's happening. So, Carl, where do these findings leave us? What are the broader implications of this research for our understanding of consciousness and the dying brain?
Well, the traditional view has been that the brain becomes hypoactive during death, but this study, along with the rodent research, suggests a more complex and dynamic process. It seems there's a flurry of activity, a final surge of energy, before everything goes quiet. This opens up a whole new avenue of inquiry into what happens in those final moments.
Absolutely. It raises fundamental questions about the nature of consciousness. If this gamma activity is related to memory recall, as the researchers suggest, does it mean that consciousness, or at least some form of it, persists even after clinical death? Or is it simply a physiological response, a final electrical flicker of a dying system?
That's the million-dollar question, isn't it? We need further research to determine whether this activity reflects a conscious experience or a more automated process.
I agree. And it would be crucial to incorporate more sophisticated neuroimaging techniques, perhaps combining EEG with fMRI or PET scans, to gain a more comprehensive understanding of the brain's activity during death.
Definitely. Comparing the subjective reports with the objective neurological data could provide invaluable insights into the relationship between brain activity and conscious experience during the transition to death.
This research is really just the tip of the iceberg. It opens a door to a deeper understanding, not just of death, but of life itself. What is consciousness? How does the brain generate subjective experience? These are some of the biggest mysteries in science, and this research offers a tantalizing glimpse into potential answers.
It's a complex and sensitive topic, but this research offers great insights.
A huge thank you to our listeners for joining us on this episode of Paper Pills. We covered a lot of ground today, from the Estonian study that accidentally captured a dying brain's activity to the different types of brain waves and their associated mental states. We also explored the significance of increased gamma activity and its potential link to a replay of memories during near-death experiences.
And we certainly didn't shy away from the limitations of the study and the need for further research. It's important to be both curious and critical when exploring such groundbreaking findings.
Absolutely. We'd love to hear your thoughts on this episode. Share your comments and questions with us on our website or social media platforms.
And don't forget to subscribe to Paper Pills for more explorations into the interesting world of scientific research. Until next time, stay curious.